Today's video is going to focus on permutations with specific arrangements. Before we begin, we will remind you of the two different buttons that can be used with permutations. The first one is the factorial button, and that is when you are arranging all objects. And the second button is the NPR, is when you're only arranging some objects. There are three categories of examples. The first one is if you have a permutation and there are restrictions where certain places are reserved for certain outcomes. So in this example, using all the letters of the word secondary, how many arrangements are possible if the first letter is a vowel? So what we have here is 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 letters. If we were just arranging all of them, it would be 9 factorial. But the problem here is that we have to make a restriction that the first has to be a vowel. So we have 9 tasks to fill. The first letter here has to be a vowel. So let's see how many vowels there are. E, O, and A. There are 3 possible vowels. So there are only 3 outcomes that can go in the first position, because that has to be a vowel. After that, you have no restrictions at all. So after that, after you've taken out the one vowel, that leaves 8 letters left to go there. 7, 6, 5, 4, 3, 2, 1. This is an AND situation because you were using all the letters and you're arranging all of them. Or you can write this as 3 times 8 factorial. And that works out to 120,960 arrangements. So for full communication marks, once again, I'll remind you that you've got to put in that unit there. And you also have to use either the n factorial or the NPR in proper notation whenever possible. So if you just wrote this and got the answer here, you would get full application marks, but you would lose some communication marks. So this right here is the restriction. And the restriction is always where you want to start. And then after that, you place what's left over. So all of this is what's left over, and this can be anything. So place your restriction first, and then see what's left where anything can go and fill that in afterwards. Here's another one. The middle letter must be a consonant and it must be beside one vowel only. If your sheet does not say that, could you just please change your sheet to say that if I haven't edited it already? So the middle letter must be a vowel, and so it must be a consonant, and it must be beside one vowel only. So here's your 9 letters. The middle number must be a consonant, and it can only be beside one vowel. So here's the vowel that it's beside, which means that one cannot be a vowel. So there are 6 vowels to go in the center. 6 consonants to go in the center. There's 3 vowels that can be beside it, and it can only be beside one vowel, so this one must also be a consonant. After that, there's no more restrictions, so there's 6 letters left, so they can be arranged in 6 factorial ways. So you have the 6p2 because you've got one consonant here and another consonant here. So this is 6p2 times the vowel, which is there, times the 6 factorial, which is the remaining letters. And that makes a total of 64,800. Now, the one problem with this example is consider this. Here's the consonant in the middle. It says it has to be beside one vowel only, but it doesn't say that the vowel has to be on the right. The vowel can be on the left and the other consonant on this side. So 6 consonants can go here, which means 5 consonants left to go here, and the 3 vowels. And the remaining 6 letters can be arranged in 6 factorial ways. That is also equal to 6p2 times 3 times 6 factorial. So what you can do is either add these two together, or you can just do one case. If you want to shorten your workload, just do one of these cases and multiply it by 2, because the answers are going to be the same for the 2 cases. And that's going to end up being 129,600 arrangements. So there's a couple of examples of how you handle reserved places. So always start with the restriction and then fill in the remaining parts. This next example you're going to see several times in your homework, in quizzes, exams, and tests. And they have to do, in this question, with the vowels having to be side by side. So in this question, we have 3 vowels and 6 consonants. And the 3 vowels have to be side by side. The question can also be written as the 3 vowels have to be grouped, the 3 vowels have to be together, or the 3 vowels have to be one right after the other. So in a question like this, when you have 9 letters, the 3 vowels have to be together. So what we're going to do is treat them as one object. The reason why we treat them as one object is that you can't be putting any kind of consonants in between, so they just stay together as one package. So that means instead of 9 letters being arranged, we've got 1, 2, 3, 4, 5, 6, 7 objects to be arranged. And those 7 objects can be arranged in 7 factorial ways. So the 7 comes from the 6 consonants, and the 1 block of vowels. So that's where the 7 comes from. Now, even though the 3 vowels don't have to be first, they do have to stay together, but the 3 vowels, which are A, E, and O, it doesn't say which order those 3 vowels have to occur. So the 3 vowels can also rotate, and they can be arranged in 3 factorial ways. So as these 7 objects are being arranged, the 3 vowels are being arranged within that arrangement. So you also have to consider the fact that the 3 vowels are also being arranged. So you have 3 vowels arranging themselves within this 7 objects arranging themselves. So that's going to be 7 factorial times 3 factorial, and that works out to 30,240 arrangements. So please make note of this because this question you will see often. So this is definitely a question that you want to study for. Doesn't have to be vowels. It could be you're arranging textbooks and the 3 math books have to be side by side, or you could be arranging the 9 players of a baseball team and the 6 infielders have to bat one right after the other. Any question like that, you do the grouping, you count the number of objects, including the grouped object, as the first part, and then the grouped objects you also have to arrange. So please watch out for those questions. The last type of example are questions that involve the word at least one. And the key is it's at least one. So that means 1 or 2 or 3. So in this case, this is an NPR example because we are only using 3 of the letters. So in this example, there are 3 vowels and 6 consonants. So to have 3 letters, that means we can have 3 vowels and no consonants, 2 vowels and 1 consonant, 1 vowel and 2 consonants, or 0 vowels and 3 consonants. There's 2 different ways to answer this question. One way would be particularly difficult, which would be to take all of the cases that we want, which are the cases that have at least 1 vowel, which means this case, and this case. It would actually be a lot of work to figure out how many ways you could have 3 vowels, 2 vowels, or 1 vowel. So what's easier is to take the total number of cases and subtract the case you don't want. So the only case we don't want is for there to be 0 vowels and 3 consonants. So if you take all the cases and remove the case of 0 vowels, that leaves you with the case of at least 1 vowel. The total number of cases is 9p3 because we have 9 letters and we are arranging 3 of them. The number of cases with 0 vowels and 3 consonants is, well, there's 3 vowels. We're not going to arrange any of them. And there are 6 consonants, and we are going to arrange 3 of them. And that gives you 384. Now, 3p0 isn't actually needed because anything p0 is equal to 1. So you could just write 9p3 minus 6p3, but it doesn't matter if you want to include that 3p0 or not. So in this example, you have to look for the word at least. And so anytime there is the word at least, you're taking the total number of cases and subtracting the case or cases that you don't want. In this case, or in this example, there's only 1 case that you don't want. So those are your 3 different groups of questions. So reserved places, grouping items, and at least 1. What I'd like you to do is to try these 3 examples. They're very similar, so reserved places, grouping, and at least one. So what I want you to do is to pause the video, try the examples, and come back and check the video. All of the examples we did were arranging letters in a word. It's the same as arranging books or arranging people or arranging friends in a line or arranging baseball players. It doesn't matter what you're arranging as long as you are arranging something, because that makes it a permutation. So pause the video, try these 3 examples, following along the examples that I provided for you, and then come back to the video and check your answers. So pause now, please. Welcome back to the video. I hope you actually gave these a try, and let's check your answers. So in this example, a student has 9 different books. We've got 3 math, 6 different books. A math book must be on the ends. So the first must be a math book, so there's 3 possibilities. The last must be a math book, so now there's only 2 possibilities. The middle one cannot be a math book, so that means it has to be one of the different ones. So there are 6 possibilities. Those are your restrictions. After those restrictions have been met, the 6 remaining books can be arranged in any of the remaining spots. So the math book's on the end, 3 times 2 is where that 3p2 comes from. The 6 in the middle is there, and the remaining 6 books can be arranged in 6 factorial ways. Question 2. You have 8 people in total, but 4 of them want to sit side by side. So those 4 people you're going to group together. So that means you've got 4 other people plus the group to arrange. So that's 5 factorial ways to do that. Then the 4 people that want to sit side by side, doesn't say what order they have to be, so those 4 people can be arranged in 4 factorial ways. Question 3. This is an at least one question. At least one. So there's 3 outfielders, 6 infielders. We need 4 people. So that means you could have 0 out, 4 in, 1 out, 3 in, 2 out, 2 in, 3 out, 1 in. You can't actually have 4 out, 0 in because there's only 3 outfielders. That doesn't matter anyway because you're going to take the total number of cases and subtract the case you don't want. The case we don't want is no outfielders because we want at least 1 outfielder. So the total number of ways, there's 9 people in total. And 4 of them is what you're arranging, so that's 9p4. And the case we don't want is none of the 3 outfielders and 4 of the 6 infielders. So that's it for permutations with specific arrangements. If there are any questions that you didn't understand, make a mark of it on the paper by the question and ask your teacher the next day. Thanks. Bye-bye.